Good morning. Today we are going to discuss continuity of a function at a point. So till now we have done that a function, if you are taking, it has its limit existence at certain point x is equal to a if your left hand limit is equal to right hand limit. If left hand limit equal to right hand limit of the function at x is equal to a, then we have done one thing, that limit x approaches to a fx exists at x is equal to a. This part we have done. That is left hand limit and right hand limit, their limits are approaching to the same value. For example, this is the graph I am taking. Here in this case, from left side when I approach, the value of the function is going towards this point. Same way on the right side, the value is again approaching to the same point. It means left hand limit, right hand limit, both are approaching to the same value. So whenever left hand limit and right hand limit are approaching to the same value at x is equal to a, then we will say yes, function's limit will exist. But now we are concerned about the continuity of the function. When we are concerned about continuity of the function, the problem comes of this point. Till here the function is clearly continuous. Continuous means without break we are joining the curve. So here in this case we will find the curve is joined till here. Same way curve will be joined here. But only the problem at x is equal to a, we don't have the value. Till now we have not discussed about the value at x is equal to a. Now in this case, first time if I say the left hand limit is going towards the same value, right hand value is going towards the same value, but the function's value at x is equal to a is somewhere here. X is equal to a, this is the value of fa. If it is fa, then what you will find in this case, we will say left hand limit is equal to right hand limit, that is clear, and it is not equal to the value of the function. That means this curve is broken at x is equal to a. This curve will go nearer and nearer to this point x is equal to a. This will go nearer and nearer to x is equal to a, but never join because the value of the function at x is equal to a is here. So this will be the first case where the function come out to be discontinuous. Why it is discontinuous? Because left hand limit, right hand limit both are approaching to the same value, but at particular point x is equal to a, the function's value gone to some other place. Second condition is here, in which what you will find, left hand limit is approaching here, right hand limit is approaching here. Both are finite number, but what we will find here, left hand limit is not coming equal to right hand limit. So this is again a discontinuous condition. This is a discontinuous condition. Why it is discontinuous? Because you can't make the curve continuous till this value shift here. If you take x is equal to a, this is the point here. If the value of the function gone fa, which is here, if that will shift here, then automatically the function will become continuous. Same way here, what you will find that this value and this value, there is a big gap. And if we want to join them, there will be this way we are going to join this. When you are going to join this at x is equal to a, you will be having infinite value of the function. This is also fa, this is also fa, this is also fa, this is also fa, this is also fa. So at x is equal to a, there are so many values of fa, which is not possible because in function we have done at x is equal to a, or we will say whenever you have a function, each and every element a has a unique image this side. And if it is not unique, we will say it will not be a function. So this condition is also going to fail. So these are the two conditions I told about the discontinuity. In what case it will become continuous, we'll consider. So in this case, first case I told you left hand limit is equal to right hand limit but not equal to the value of the function. Whenever this stage comes, we will say continuity does not exist at x is equal to a. Function is not continuous at x is equal to a. Function is discontinuous at x is equal to a. And this type of discontinuity we call as removable type of discontinuity. Removable type of discontinuity. So this will be a removable type. Why we can say removable? Because this we can remove by simply changing this point from this to this. Then it will remove and we will say the function will become continuous. So this is the first type of discontinuity. Second one, in this case, you can't remove it. There is a big gap. By a single point change, we can't make the function continuous. So that means we will say yes, it will be a discontinuous case. So function is discontinuous here also. Function is discontinuous at x is equal to a, and this is called first kind of discontinuity. Okay, this is the first type kind of discontinuity we have. This is removable type, this is first kind of discontinuity. Now we are coming on the third case in which we will find this condition. I'll just make it once more. Here in this case, let the left hand limit goes towards this and a also give this value. So this is approaching to this value. Okay. And second condition is that from this side, the curve which you are going to have going like this. Then what you will find, left hand limit is going towards infinity. This is going towards FA. What you will find in this case, left hand limit is going towards infinity. Right hand limit will go towards FA. So what you will find, one limit does not exist, second limit exists, and that is equal to FA. So till here the function remain continuous, but at this stage, after this you can't join these two curves, so it will be again a discontinuous case. This is called second kind of discontinuity, where left hand limit does not exist or maybe right hand limit does not exist. In this case, I have shown that left hand limit does not exist. Maybe this curve goes this side, this goes towards infinity, that goes to some finite number. We will say yes, this will be second kind of discontinuity. In this second kind of discontinuity, one more possibility is also there. What that can be, just check here. This is x is equal to a and value of the function is here at x is equal to a. This is your FA, and let the curve from this side goes like this, going towards plus infinity, and from this also it is going towards infinity. So I can't join them because this is going towards infinity. So what I should say in this case, left hand limit going towards infinity, right hand limit going towards infinity, and we will say FA is there. So what I should say, these two are not existing, then there is no meaning of FA here. We will say we can't make function continuous. So this and this case are one and the same thing. This is called second kind of discontinuity. So how many discontinuities are there? Three cases are there in which the function can be discontinuous. One is removable type, another is first kind, then the third, second kind. So in question, they can ask what type of discontinuity is there. And if the function is continuous, then what condition must come? Just check here. If you want the function to be continuous, that means I'll just go on the same example as you have taken the first one. This is x is equal to a. In this case, if you have left hand limit and right hand limit, both are approaching to the same value. Left hand limit and right hand limit both are going towards the same value, and function's value FA is also here. This is also FA. So if it is FA, so that means this will be going to connect. And when you get this, all the three are there, we will say this function will be without a break. We will say this function come out to be continuous. So here we will say that if you want the function to be continuous at x is equal to a, then your left hand limit, right hand limit, and value of the function has to be same. So here a function. Now what is the condition we have for the function to be continuous? A function fx is said to be continuous at x is equal to a. If, what is the condition? Left hand limit equal to right hand limit equal to fa. Left hand limit means limit h goes towards 0, or first you can write this way, x approaches to a minus fx equal to limit x approaches to a plus fx is coming equal to fa. Or you can say this also, limit h goes towards 0, f a minus h will be limit h approaches to 0, f of a plus h come out to be fa. So if this condition, which is same as this and same as this, if any one of the condition you can take, or you say left hand limit, right hand limit and value of the function, if all three are coming same, we will say function is continuous. If any one condition fail, I told you 3 times of discontinuity. So if any of the case comes removable type, in that you will find left hand limit, right hand limit are equal, but this is not equal. Second, first kind I told, in which these two are not equal. In third case, I told you either left hand limit or right hand limit or both are going towards infinity. So that will be the case of discontinuity we have. So function is said to be continuous if you have left hand limit, right hand limit and value of the function come out to be same. So I think it is clear how to check the continuity of the function, and you know how to calculate the left hand limit, how to calculate right hand limit, and then we can decide whether the function is going to be continuous or not. In the previous question or previous class, fa we have not taken in consideration. Now we are bothered about fa also, because that will be going to decide whether the function is continuous or not. Okay, so this way you are going to solve the question. I'll be starting with the question in next video.